It's also ready to calculate the volume of fill that is going to be necessary to meet the requirements that you've just given it. And so at the command line, it says, do you want us to calculate the volumes? It defaults to yes. Well, let's take a look at it by taking the default. A lot of information will be presented to you. Some of it is information that you provided the program up to this point. The slope ratio that we're using. But where the information that you're going to find useful is at the bottom of the screen, total fill. And it gives it to you in cubic feet, and then it converts it into cubic yards for you. Now you'll notice right above the fill requirement is the cut. It's giving you some positive numbers here. They're small numbers. 5/100ths of a cubic yard is a small number. But for the longest time that bothered me, and I discovered that when you make the grid number that we talked about earlier a larger number, and you could experiment and you could put in 1,000 X and 1,000 Y, it generates a very accurate surface which it uses to come up with these numbers. And then you'll find that that cut number will be 0 or very, very close to 0. So don't be too bothered by seeing some small numbers here when we know there'll be no cuts involved in this field. So these numbers here, these fill numbers, would be useful if you're going to place a bill of material with estimated fill requirements on the plan. And you'll also remember the first dialog at the bottom asked us for a fill factor. It would take that factor and it would multiply it times this number, which is the calculated volume, but we all know that the fill requirements might actually be a little bit higher than that because it will settle once it's in place or as you place it. So some designers would choose to add 10, 15, or maybe even 20%. So that fill factor you would use 1.1, 1.15, or 1.2. That is entirely up to you. So there is a very useful piece of information. It also can provide you with some really quick design information if you're looking at a relatively gently sloping site and you can't quite decide, well, should I go sloping or flat bed, and it doesn't matter to your client other than save me as much money as you can. Well, this number would be important. You could run the field as a sloping bed, and you could also check it as a level bed, or the pad slope would be 0. You can choose to save this information, print it. You can even print it to the drawing itself. We're going to choose to exit. And now we haven't left the command. It's continuing now to ask us questions. It gives us an opportunity, if we've made a mistake, to go back and redesign it. We're just going to say no, which is the default. Do we want to write the grid file that we just created to an electronic file? If you plan to use that information again at some point in the future, then save it. They're not very big, they're just text files. But I typically don't because it's so easy to create it again. Trim existing contours inside the pad perimeter. I don't like to trim the existing contours or the existing terrain contours, so I answer no here. I always want the regulator and the contractor to see what the existing terrain is doing under the fill. Now it asks us, do we want to contour this pad? And we do, which is the default, so we'll say yes. We're presented with another dialog, and we can keep it very simple. It wants to know a layer to put these contours on. and I put P contour just for proposed contour. Name it anything you like, anything that's meaningful to you. The contour interval is identical to the contour interval when we contoured the existing terrain from our point data. Some designers like to show 1 foot intervals for their proposed contours. Again, I prefer 2. And then these other options you can experiment with. I don't typically use them, including this label contours. I'm going to leave it checked this time so that you can see what it does, but it's a little quirky. It puts the contour label in some odd spots that I've yet to figure out exactly how to control it consistently. So I typically will label my contours, my proposed contours, manually, as we did our terrain contours in an earlier tutorial. But I'm going to leave it checked so that you can see what it does. We can leave these other things unchecked. I prefer to leave the polyline vertices, reduced polyline vertices checked. We don't have to talk about what that's about. We just want to keep this as simple and easy a process as possible. Feel free to experiment with this stuff. Say OK. It then brings up a final dialog, but it's related to contour labels. Now, if you had unchecked the contour label option, you would not be presented with this dialog. So now it wants to know, what layer do you want to put those labels on? The text size scaler, which can be a little confusing. Again, whatever your drawing scale is, typically it will be 20 to 1. 1 inch equals 20 feet. You will use this as a multiplier. So if we want our text to be a specific height, let's say we want it to be 1.6 feet high, you would say 1.6 divided by whatever your drawing scale is, and that's the number you put here. I've put in a pretty small number so that the text height is going to be about a foot high, so that you can see it, so that it's readable, and you'll have to experiment again based on the scales that you choose to draw in. Then you come down through these checkboxes. I like to break the contours at my labels, so I'll check that. We can also draw a box around the text to make it a little more visible. And then I normally will only check 1 label per contour in this case. And say OK. And there it is. It drew them that quickly. And you see what I mean about the label, this 102 label. It put it in a spot that I can't quite understand why, and I can't offer any practical suggestions to help you eliminate that issue. Now you're going to notice that it is not exactly correct. That 102 contour should run right through the center or very close to the center of the highest row elevation. And it's all related to that pad elevation that we gave it earlier. Now if you want these contours to come out more accurately, then you're going to have to do the math, which means find the distance from the center of the highest row to the edge of the pad, and then multiply that times your slope. So I can just walk through that with you. Well, let's come back here. Let's measure the distance from the center line of that row to the edge of the pad, and it has to be perpendicular, and it's 12.9, so we could use 13 if we cared to, but we'll use the numbers that are provided. So we have 12.9 feet, and our slope is 20%, or 0.2 feet change in vertical elevation for every foot. So 12.9 times 0.2 is equal to 2.58 or 2.6. We want to subtract this change in elevation from the finished grade over the highest row, which was 102. So we'll just change the sign of that value to negative and then say plus 102 equals 99.4. Now you'll remember we used 99.1. So if we wanted to perform this calculation before we went into the routine, you'd find that contour would be much closer to the center. I'm sure it would be over the top of the first pipe. Sometimes I'll take the time to do that. That's your choice. Now I've taken the liberty of drawing a profile the old-fashioned way, and just to show you what we've just done. So we have a sloping bed, and 5 feet beyond the edge of the field we change our slope to our 3-to-1, and at some point it intersects the existing terrain. And you'll find that if you want to work through this manually, you'll find that what Carlson provides you is very accurate. And again, it's going to be as accurate as the information you give it. So this can be done very quickly, and it is far easier to use this routine for sloping beds to create your proposed contours than it is to do it manually, which we did in a prior tutorial.